Today we're going to talk about vectors. And vectors are important and they tie in with matrices because you can reflect, you can rotate them, you can do all of those different operations using matrices and vectors. Um, but before we get started, we kind of need to talk about what is a vector, how does it look graphically, and all of that good information. So to start with, a vector, by definition, which I'm sure you guys are all thinking of Despicable Me. Anyway, a vector is a quantity that has both direction and magnitude. But I'm sure you already knew that, like I said, from Despicable Me. With that being said, we need to break down how this can be written. A vector is written in component form, in which it is written like this, kind of like coordinates. Um, Instead of parentheses, we have these little arrows instead. It just tells us that we have a vector instead there. The magnitude is represented with the square root of x squared plus y squared. Sorry, shouldn't give you dead air there. Just trying to do this at home. Doesn't always work the greatest at home. But anyways, we have x squared and then plus y squared for our magnitude. And then for the direction, this is represented with actually tangent. And it's the inverse tangent, to be honest. And it's y over x. And that's going to equal our theta. Okay. Graphically, if you were to look at this, this is what it's going to look like. You're going to have something like this. Sorry. I don't know why this is not working. There we go. Where this is theta, and this here is the vector. This point here at the bottom, that point there is what we call our initial point. And this point here is what we call our terminal. Sorry, bear with me as I'm writing on my screen with my finger. It's a little challenging here. But anyway, so this is our initial, this is our terminal point, this is our vector, and then this is our angle or our direction. Okay, so get right into the examples. First thing we're going to do is represent what does the vector look like and where's it located. So we're representing it graphically. Okay, so in this situation, let's say that we have an initial point at 6, 2. And then we have a terminal point at 3, -5. Okay, so when we're thinking about this graphically, I'm actually going to go to Desmos to graph these points. It'll make it look a little easier. When we are graphing those points, we can see if the red is my initial, that means then that I'm going in the negative x direction and the negative y direction. And that's not that big of a deal. It's just something to note that we're going that way. Okay? So, because we're going, how do we go from the red point to the blue point is really what we're trying to figure out. Well, to go from the red point to the blue point, we have to go to the left 3, which is going to be represented by the x coordinate. How do we go from the red point to the blue point in terms of the y coordinate? Well, we have to shift down 7. Okay, so our vector then is going to be -3, -7. Again, we had to shift from 6 to 3 by going to the left 3, so that's -3. We had to go down from 2 to -5, so that's a -7 there. So that's our vector, and there you could see it graphically what that means. Okay, so moving on. Let's now talk about operations on vectors. So when we're looking at this, we're going to either add or subtract vectors or multiply them by a scalar. Nothing too challenging. So if we have the vectors 4, 7, and let's go with another vector of -2, 8. Okay. Vector multiplication. Vector addition realistically is not that bad. All you got to do is actually add the x coordinates, add the y coordinates. So our final answer here would be 2, 15. We just add our x's and add our y's. If we subtract vectors, it's similar concept. However, they want you to do it in a, I don't want to say goofy way, but they want you to do this in terms of adding the inverse. So what they really want you to do is take 4, 7, which would be our first one, plus the inverse would get you 2, -8. Okay, realistically, that's the same thing as if you were subtracting them, honestly, so not that big of a deal. So 4 plus 2 then gives me 6. 7 plus -8 gets me -1. So there's my subtraction of vectors. Last but not least, multiply by a scalar. So let's say my scalar factor or my constant factor is 3 and my vector is -2, 6. So what we do to multiply them is actually just multiply the 3 out, kind of like you're distributing. So it'd be -6, 18. So not bad with operations on vectors. Those ones are pretty straightforward. It's when we get into finding the magnitude and direction of the sum that can be a little bit challenging, and that's where we're headed for this next example. Okay, so a jet is flying northwest and its velocity is represented by -400 miles per hour. Okay, if you think about it, north represents the y coordinate, so we're going north, which is a positive y. West is to the left, so that's why we're going negative, okay? Makes sense? The wind is from the west, and its velocity is represented by 50 miles per hour. Okay, let's think about that. If it's coming from the west, that means it's going, starts from the west and it's going to the right. So that's why it's a positive. It's directly from the west, so we don't have any y coordinate, hence why we have a 0. So we have a couple different things to find. We need to find the resultant vector. We need to find the magnitude. And we also need to find the direction. Okay, so this isn't as bad as you think. When we're looking at this, we're going to be trying to figure out, okay, how are these two things impacted by each other? What's the magnitude and what's the actual direction of that jet? So when you look at this, the resultant vector, we're just going to add these together. So when we get our resultant vector, if we're adding them together, we get negative 350 and 400. So now we can find that magnitude and direction using that resultant vector and just using those formulas that were given to us. So the magnitude, remember, is the square root of the x squared plus the square root of the y squared. So we just actually go ahead and calculate that. And we would get 531.507 miles per hour. Okay. The direction is using that tangent, remember? So this is going to be tangent -1 of our y over our x. So when we type that in, make sure that you are in degree mode, just to double check. So when we do that, we get negative 48.814 degrees. Okay, and there's our answers there. So that gives us our magnitude, that gives us the direction. When we're talking about the direction in terms of that theta, I know it has a negative there, but that's just telling us, if you think about direction, direction is, if it's a negative, it's to the left, or it's to the downward section of our coordinate plane. So there is vectors in a nutshell. Most of the time it's pretty straightforward, but best of luck with this.